All right, welcome to The Explainer. Today we're jumping into something that's a real game changer in AI. It's a technology that's fighting back against those weird hallucinations from AIs and making them way smarter and more reliable. We're talking about Retrieval-Augmented Generation, or as you'll hear it called, RAG.
So you've totally been there, right? You ask one of these super powerful AIs a question, maybe about something that just happened or a really niche topic, and what do you get? Either an answer that's just confidently wrong, or you get that classic, sorry, I don't have information on that. It's so frustrating. You got this amazing tool, but it just hits a wall.
And this right here shows you exactly what I'm talking about. On the left, that's your standard large language model, an LLM, just trying to answer from memory, and its knowledge is basically frozen in time, from whenever it was trained. But look at the right. That's the same question, but answered by an LLM that's using RAG. The difference is just night and day. It's detailed, it's specific, and it's using current info.
So here's the key thing to get. The problem isn't that the AI has a bad memory. Not at all. The problem is that its memory is locked away, totally cut off from the real world, which, is always changing. It just can't access up-to-date facts. Well, that is, until now.
So how does this all work? Well, Retrieval-Augmented Generation, RAG for short, is this really clever idea that completely changes how an AI finds an answer. Instead of just digging through its own static internal knowledge, RAG gives the LLM a new superpower, the ability to go and look things up in an external library of information before it even tries to generate a response. This could be anything, a company's internal wiki, technical manuals, you name it.
Okay, the absolute best way to think about this is like the difference between a closed book exam and an open book exam. A regular LLM, it's taking a closed book test. It can only use what it's already memorized. But RAG turns that into an open book test. Before the AI answers, it gets to look at a cheat sheet of super relevant notes, making sure its final answer is actually based on facts, not just what it remembers.
So let's break it down, starting with the first version of this tech. People often call it naive RAG. Now, don't let the name fool you. It's simple, it's elegant, and it really did set the stage for everything that followed.
It basically works in three main steps. First up, indexing. Imagine you have a ton of documents, like thousands of PDFs. The system takes all of them and chops them up into smaller, manageable chunks. Then it turns those chunks into numbers. We call them vectors, which is just a fancy way of saying it captures the meaning of the text. All that gets stored in a special database. Step 2 is retrieval. When you ask a question, the system searches that database to find the chunks of text that are the most similar in meaning to your query. And finally, step 3, generation. Your original question and those top-ranked, super relevant chunks of text get bundled up and handed over to the LLM. And that's what it uses to build a really well-informed answer.
And this diagram really shows you that whole process in action. The magic really happens in that middle step, where your prompt gets combined with all that context it just found. See, by feeding the LLM not just your question, but also the relevant facts it just retrieved, we're giving it all the ingredients it needs to cook up a factual, detailed response. It's a simple idea, but man, is it a powerful one.
But, this basic, naive approach wasn't perfect. It had some issues. Sometimes the retrieval step would grab irrelevant stuff, or even with the right info, the LLM might get confused or spit out a really disjointed answer. And if you're pulling from a bunch of different sources, you could get repetitive or even contradictory information. Clearly, the process needed to get a little bit smarter.
And that, of course, brings us to the next step in the evolution, advanced RAG. This is all about adding some extra layers of intelligence to fix the weak spots of that basic approach.
This is such a great way to see the difference. Over on the left, you've got that simple, straight line of naive RAG we just talked about. But look at the middle diagram for advanced RAG. See those new boxes? It adds two really important new stages, pre-retrieval and post-retrieval. So it's not just a simple fetch and generate anymore. It's doing some thinking before and after. So what do these new steps actually do? Well, pre-retrieval is all about sharpening the question before the search even begins. If your query is kind of vague, it might rewrite it to be more specific. Post-retrieval then acts like an editor for the search results. It takes what it found, re-ranks it to put the most important stuff on top, gets rid of anything repetitive, and basically tidies it all up so the LLM can focus on what really matters. But the evolution doesn't stop there. The latest and greatest approach is what we call modular RAG, and this is where things get really cool. It transforms that linear pipeline into a super dynamic and flexible toolbox. Just look at this diagram. You can see right away this isn't a fixed, one-way street like the other models.
Modular RAG is more like a collection of interchangeable parts, or modules, that you can mix and match in all sorts of clever ways. Think of it less like an assembly line and more like a workshop full of specialized tools you can use for any job.
And this toolbox is packed. You've got different modules for search. You've got modules that can rewrite and improve your query as it goes. There's even a routing module that's smart enough to decide which knowledge base is the best place to look for an answer. So for a question about stocks, it might check a financial database. For a science question, it might search through academic papers. It's all about building a system that can tailor its strategy for every single question it gets.
Okay, so now that we've seen how RAG has grown up, you might be wondering, where does this fit in with all the other ways we try to improve AI models? And that's a great question, because it's not the only tool out there. It's often compared to another big one, fine-tuning.
This chart really maps it all out for us. So on the vertical axis, you have how much you need external knowledge. On the horizontal, it's about how much you need to actually change the core AI model itself. You can see prompt engineering down at the bottom. It's pretty simple. Fine-tuning, on the other hand, is all about changing the model, but it doesn't necessarily add new facts. And then you have RAG, way up there on the external knowledge axis. It was literally designed for tasks that need fresh, verifiable information from the outside world.
And here's the bottom line. You use RAG when the what of the answer is most important, when you need facts that are current and can be checked. You use fine-tuning when the how of the answer is what you care about, when you want the AI to talk in a certain style or adopt a specific personality. They're not fighting each other. They're complementary tools for different jobs.
RAG has come a seriously long way, but the journey is definitely not over. Researchers are pushing the envelope right now, trying to solve some even tougher challenges.
One of the biggest frontiers is making the whole retrieval process smarter, almost like teaching the AI to think like a human researcher. So instead of just one simple search, we're seeing new methods pop up. There's iterative retrieval, where it searches multiple times to build up a better picture. There's recursive retrieval, which can break a big, complex question down into smaller, searchable parts. And maybe the coolest of all is adaptive retrieval, where the model itself learns to decide if and when it even needs to go look something up.
So looking ahead, what's next for RAG? Well, the big challenges are pretty clear. People are working on teaching it to understand more than just text. We're talking tables, charts, even images. They're trying to figure out the perfect chunk size for different types of information. And maybe the biggest one of all is making sure the AI doesn't just, copy and paste the facts it finds, but that it truly understands and synthesizes them into something new and insightful.
When you really step back and look at the whole journey, from that simple, naive RAG to advanced and now to modular, you see this really clear path. We're moving away from a simple search and retrieve machine and getting closer to a truly dynamic, intelligent conversation between an AI and all the data in the world.
And that leaves us with a pretty cool final thought. What RAG is really doing is giving AI its own library card. A library card to a library that's constantly being updated and is infinitely large. This technology is no longer just a brain in a box. It's becoming a researcher with access to pretty much everything. So the real question for us is, as we give AI its own library, what's the very first thing we should ask it to read?